from architecture. Obviously, we have a lot of architectural elements in games, things like level designs, a lot of spatial relationships. There's actually a lot of learning from architecture as a field, because architecture, unlike a lot of design fields, has looked at the process of design separate from the process of what it designs. So there's a lot of architectural theory around how to make a good building, but there's also a lot of theory around the design process itself. How do you iterate? How do you prototype? How do you think about problems and decompose them? One of the most influential books for me has been this one called A Pattern Language by an architectural theorist named Christopher Alexander, in which he kind of deconstructs a lot of design rules into very simple patterns that he's found that he can reapply and recombine when he's designing anything, whether it be a house or an entire city. In some sense, it's almost like the Western version of feng shui, which is kind of a compressed representation of a lot of design rules, with mnemonics kind of behind them. Feng shui has a lot of kind of rules about the qi and the sha and how it flows to a structure. But really, if you look at the practical advice, it's very practical stuff, like don't hold your home in a floodplain, or avoid, things where your back is to the door. So in both of these cases, they're compressing a lot of design knowledge in a very compressed rule set that you can kind of recombine almost like Legos when you're designing something. In architecture, you'll also see a lot of kind of interesting failure cases. A lot of architecture has become very much about form and statement and kind of state-of-the-art, very art, as opposed to function. What does it feel like to actually be in a structure? There was an example, actually, a famous architect in the US, Richard Meyer, was asked to design this development center for mentally handicapped children. And, he spent a lot of time thinking about this, and built this state-of-the-art thing, and before it opened, it won all these architectural awards. People were talking about how beautiful the materials were, and how open and airy, how much light was in the space. But at the end of the day, when the people actually wanted to move into this, they found it absolutely unusable for mentally handicapped kids. You had these kind of open stairwells, and you had glass walls that kids could walk into, again, these were developmentally disabled kids. And so it ended up being completely inappropriate for what it was supposed to be. But yet at the same time, the architectural critics were lavishing all these awards on it. So really, the architect in this case was serving the architectural community, not the actual customer. This is something that actually Sid Meier, the designer, pointed out to me a long time ago. There are a lot of games that when you play the game, you can kind of tell the designer was designing a game for himself, not for the players. He got so caught up in how cool the graphics were, how elaborate the simulation was, he forgot at the end of the day that a player needs to come up to this thing and have an enjoyable experience. So that's something you can never lose, sight of as a designer. That at the end of the day, the person playing your game is with all of those design decisions that you're balancing, all those trade-offs you're making, have to be around the emotional and experiential, experience of the person coming up to your game. Japanese gardens have actually found to be a huge wealth of kind of design knowledge. It's been accrued over hundreds of years. In some sense, they become like models unto themselves. They're like these little microcosms of not just nature, but also man's relation to nature. They're very beautiful, very sensory. There's a grammar, a very definite grammar to Japanese gardening, along things like, the way you lay out the topology, the actual structures and the symbolic meanings of these. And these things are kind of recombined to make statements in interesting ways. And again, it's not just nature, but it's also kind of man's relationship to nature that they're modeling in these gardens. They have a huge amount of symbolism. They have a very famous book called The 48 Named Rocks, where different shapes of rocks represent, specific elements of culture or history, etc. They use these rocks in interesting ways. Some of the very early Japanese gardens were in fact narrative gardens from like the Heian era. And the idea is they would take a very famous book or poem and build a garden around it. And by looking at the rocks and mapping the rocks to the symbolic meaning of them, as you walk through the garden, in some sense, the poem would be encoded in the garden. And this is really kind of a game that aristocrats would play as they would walk through the garden, trying to interpret and map the symbology they saw in the garden to the story that they knew by heart. And it was kind of an intellectual puzzle game in some sense. Later Japanese gardens, around more the Meiji era, became more sensory. And they were about vibrant colors and forms and textures. And it was almost more of a Zen experience where you weren't trying to overtly interpret what was in the garden, but just kind of let it flow into you. The really interesting aspects of the way they use space, a lot of lessons that we can learn from games, involving things like foreshortening on hillsides to make the space expand. A lot of the paths in Japanese gardens will have very irregular stones. And the idea is that as you're walking through the garden, you actually have to stop and look at where you put your feet And because of the fact that you're focusing on where you put your feet, the distance that you traverse seems much longer than it actually is. So you can take a very compact space and make it seem vast. And these interesting perceptual tricks are things that we can draw almost directly from in games. There's also a really interesting time relationship, where they think about this garden not just of how you move through it in a spatial sense, but how does the garden kind of go through the seasons, and how do the forms change so that the same garden will seem radically different at different times of the year. But at the end of the day, one of the most interesting lessons I think I've learned from Japanese gardening is the idea of the value of simplicity. There's a famous quote that I've always liked, which is that your garden is not complete until there's nothing else you can remove. Really, it's about, the most amazing design artifacts are usually achieved by removing stuff, not by adding stuff. It's very easy when players kind of write and say, oh, you should do another version of The Sims, except you should add this, 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 and this, and they just start piling on features. And if you made that game, it would just basically suck. As a designer, really the hard part is how much stuff can you take out of the game and still have it feel like a cohesive whole. Another kind of thing about Japanese gardens that are interesting is that in some sense they become middle tools. Places where your imagination kind of flows in and fills in the blank. And really these are things that are meant to evoke a lot of imagination out of the person, as you're sitting and meditating over things like rock gardens. But also as an art form, they transition through time in really interesting ways. It's not a static art form. Every 100 years, it's almost reinvented itself. Even today, it continues to be reinterpreted in interesting ways as culture moves forward. I think Go is one of my favorite games of all time. Embodies a lot of these principles. It has utter simplicity of the rule structures, yet these kind of amazing kind of strategies that kind of unfold as you're playing it. And so I think this is kind of almost a direct representation of how you take design learning from a field like Japanese garden and bring it into something like game design. Automotive design is another one that, it's a hugely complex artifact, designing a car. If you think about it, really, the complexity of designing a modern car is roughly equivalent, I think, in kind of design terms, to a modern computer game. There's a huge amount of engineering involved, like computer games. There's a lot of kind of art and form and style, and there's a usability factor, where this is something that a person is going to go in and have to use and learn, to kind of be comfortable inside of. Interface design, if we look at techniques that automotive designers use for studying and developing their interfaces, we are applying a lot of these techniques already in the interactive field. The idea of heat maps, this is where we can actually instrument somebody's eye and get a sense of where they spend their eye tracking on. So when somebody looks at a web page, they can build heat maps like this and show which areas of the page your eye spent most of its time on. And these were techniques that were actually developed for instrument panels in the aerospace industry and the automotive industry. What we'll do with a lot of things is we'll take, in fact, and instrument our games, where we can actually look at the buttons on the interface and measure how often is the user actually clicking on this button. And this is a totally automated measurement. And we can take these metrics and give us a lot of insight into the way the player is using the game, maybe in ways that we didn't expect. And we can kind of reorder the priority and the prominence of various interface elements. You can also do this kind of on a game-wide basis, where you can actually look at the activities that somebody's doing in a game and measure the frequency. And again, very frequently, this will bring up very non-intuitive relationships that you couldn't see any other way and cause you to reassess how important are these verbs and these actions that the player is doing in the game. Now, racing is an interesting relationship to automotive design because, racing is really a set of invented problems that, if you look at most of the really interesting technology in auto design, it's come from racing. And in some ways, computer technology has the same relationship to the game industry. The game industry has probably done more to advance, consumer computer science than anything else out there because games are always pushing the boundaries. Things like performance, graphics, sound, etc. So games are to computers basically like racing is to the automotive industry. A lot of the challenges, are very interesting. There was a recent thing, the Dormant Grand Challenge, where they were building cars for a race in the US, an autonomous race, no drivers involved. Basically, the car had to go about 150 miles across the desert from point A to point B, all by itself, with no human intervention whatsoever. And it was really interesting. The first year, they all basically failed miserably. The farthest car got maybe 10 miles. About a year and a half later, we ran the race for the very second time, and about 5 cars finished the whole 150 miles without crashing once. It was amazing how much just giving that invented problem to a set of motivated engineers advanced the state of the art of robotics and auto design. Concept cars are actually interesting too because the automotive industry does a lot of exploration, design exploration, kind of absent of production constraints. They don't worry about how much does this car cost to make, or is it really practical, but they explore